You think gravity pulls you toward the Earth. You feel it right now, pressing you into your chair. It seems obvious. But I must tell you, there is no pull at all. That sensation you trust so completely is an illusion, and the truth is far stranger. Let me ask you to imagine something. You are standing in an elevator, alone, no windows. Suddenly you feel yourself pressed harder into the floor. Your knees bend slightly under the extra weight. Now, without looking outside, answer me this. Are you accelerating upward, or has gravity suddenly become stronger? You cannot tell. The feeling is identical. This troubled me for years, this perfect symmetry, until I realized it was not a curiosity. It was a clue. We call objects in freefall weightless. An astronaut floating in orbit. A coin dropped down a well, they feel nothing pulling on them. Nothing at all. But you, standing still on the ground, you feel weight. You feel pressure. Why? What is the difference? The astronaut is moving, falling freely through space. You are not. You are being held in place, prevented from moving. And that prevention, that resistance, is what you have always mistaken for a pull. Let us be precise. When you stand on the ground, the Earth's surface pushes up against your feet. The atoms in the floor, compressed slightly, resist your body with electromagnetic force, the same force that keeps solid objects solid. That push travels up through your bones, your organs, your skin. You feel compression, not attraction. Gravity is not pulling you down. The ground is pushing you up, stopping you from doing what you naturally want to do, which is to move along a curved path through something we have not yet named. I know this sounds backward. You will want to say, but Albert, I feel heavy. I feel the pull. No, you feel the push. Weight is resistance to your natural motion. Let me show you why this matters. Imagine you're in deep space, far from any star or planet, floating in absolute darkness. You feel no weight. Now suppose your spacecraft begins to accelerate, smoothly and constantly, at exactly the same rate that objects accelerate when dropped on Earth. Inside your cabin, you will feel weight return. Your feet will press against the floor. If you release a ball, it will fall, not because something is pulling it, but because the floor is accelerating upward to meet it while the ball continues in its original straight path. You cannot perform any experiment, none, that will tell you whether you are accelerating through space or sitting still in a gravitational field. They are the same. This is not a metaphor. This is not approximately true. It is exactly true. And it shook everything loose when I first understood it. If gravity and acceleration are indistinguishable, then gravity is not a force at all. It is geometry. It is the shape of space itself, bent by the presence of mass, and objects are simply doing what they always do, moving in the straightest possible path through whatever shape they find themselves in. A planet does not pull. It bends, and you, standing here, are not being pulled toward the center of the Earth. You are trying to move through curved space, and the ground will not let you. But if this is true, if gravity is nothing but curved geometry and not a force reaching out across emptiness, then something very strange must follow. Time itself cannot remain untouched. Think about what we just established. If gravity is not a force, but curved space, then light, which has no mass at all, should still respond to that curvature. A beam of light passing near the sun should bend, not because the sun pulls on it, but because space itself is warped there. In 1919, during a total solar eclipse, astronomers measured the positions of stars whose light grazed the sun's edge. The stars appeared shifted exactly as I had predicted. The light had followed the curve. Space was not flat. This was the first crack in the old world. But now we must go further. Because space and time are not separate things. They are woven together, a single fabric. If mass curves space, it must also curve time. And this is where something remarkable happens, something you can measure with a clock. Let me take you somewhere specific. Right now, orbiting above your head, there are satellites, 20,000 kilometers up roughly, moving at great speed, and inside each one sits a clock, ticking. These satellites form the system we call GPS, the same system that tells your phone where you are on Earth. For that system to work, those clocks must be precise to within a few billionths of a second. And here is the problem. Those clocks do not tick at the same rate as yours. They tick faster, about 38 millionths of a second faster per day. Why? Because they are higher up, farther from Earth's mass, in a region where space-time is less curved. Time itself runs differently there, not because the clocks are faulty, because time is not absolute. It flows at different rates depending on how deep you are in a gravitational well. Let me say that again plainly. A clock on the ground floor of a building ticks slower than a clock on the roof. The difference is tiny, unmeasurable in daily life, but it is real. Gravity does not just bend the path of objects through space, it slows the passage of time itself. The stronger the gravity, the slower the clock. This is not theory. This is engineered into every navigation satellite. If we did not correct for this effect, if we pretended time was the same everywhere, your GPS would drift by kilometers within a single day. The system would fail completely. So when you ask me why does gravity pull, I tell you it does not pull. It warps. And what it warps is not just space, but time. You are not falling toward the Earth because a force reaches out and grabs you. You are moving through time at a different rate than the space above your head. Your feet age slower than your head, by a minuscule amount, yes, but truly. The ground beneath you is deeper in the well. Time runs slower there, and this difference in the flow of time from your head to your feet is what creates the sensation you have always called weight. Let me give you the image plainly. Imagine you are walking forward, but your left foot is on ice and your right foot is on rough pavement. Your right foot slows down, your left foot keeps moving. What happens? You rotate, you turn, you curve toward the slower side. This is what happens to you in gravity. Your lower half moves through time more slowly than your upper half, and this twists your path through space-time itself, bending you toward the Earth. You are not being pulled. You are being rotated through time. Now you begin to see it. The apple does not fall because the Earth exerts a force. It falls because the ground is rushing up through curved space-time to meet it, and we, standing here, are constantly accelerating upward, held by the surface, feeling that acceleration as weight. But this raises a new question, one that will take us even deeper. Now here is the part nobody tells you. If the Earth is curving space-time, bending the fabric around it like a heavy ball on a stretched sheet, what is doing the stretching? What is this space-time we keep talking about, this thing that bends and warps and flows at different rates? I do not know. Not fully. I can describe how it behaves. I can write down the relationships, predict the bending, calculate the flow of time to extraordinary precision. But what it is made of, what gives it structure, what allows it to curve in the first place, this we do not yet understand. Space-time is not a substance you can hold. It is not made of atoms. It is the stage itself, and yet the stage responds to the actors. Mass tells space-time how to curve. Space-time tells mass how to move. But the nature of the stage remains mysterious. Still, let us work with what we know, because what we know is enough to see something astonishing. If mass curves space-time, and that curvature is what we experience as gravity, then there should be waves in space-time itself. Ripples, like dropping a stone in a pond. But the pond is the fabric of reality. Imagine two massive stars, circling each other, locked in orbit, spiraling closer and closer as they radiate energy. As they move, they churn the space-time around them, sending ripples outward at the speed of light. These ripples stretch and compress space itself as they pass. A meter stick would grow longer, then shorter, then longer again, though by an almost impossibly tiny amount. For over a century, this was prediction only. Then, in 2015, we detected them. Gravitational waves caught by instruments so sensitive they can measure a change in distance smaller than the width of a proton across a beam of light 4 kilometers long. This confirmed something profound. Space-time is not abstract. It is physical. It vibrates. It rings like a bell when struck. The universe itself has texture, and we have touched it. But let us come back to you, standing here. You now know that what you feel as weight is not a pull, but a push. The ground, preventing you from following your natural path through curved space-time. You know that time runs slower at your feet than at your head. You know that the satellites above you must account for this, or fail, but I want you to see the deepest strangeness, the thing that makes all of this unavoidable. You cannot have gravity without this warping of time, not as a side effect, not as an extra detail. The warping of time is gravity. Listen carefully. When you drop a ball, it does not fall because space is curved beneath it. It falls because time is running slower below it than above it. The ball is moving forward through time, always. Every object does this, but the rate of that forward motion differs from top to bottom. That difference tips the ball's path. It curves downward into the future, through geometry we cannot see but can measure exactly. This is why light bends near the sun even though it has no mass. Light does not experience space curvature alone. It experiences the curvature of time, and time itself is tilted near massive objects, dragging even massless things along tilted paths. The universe does not care whether you have mass. If you move through time, and time is curved, your path will bend. So gravity is not a force. It is the shape of time itself, made visible. And you have been living inside that shape your entire life, mistaking its geometry for a pull. But now one last question opens, and it is the hardest one of all. If gravity is just geometry, just the natural shape of space-time around mass, then why does mass curve space-time at all? Why does the Earth, this ball of rock and iron, bend the fabric of reality around it simply by existing? I can tell you that it does. I can predict exactly how much curvature a given mass will produce. I can show you the measurements, the satellite clocks, the bending starlight, the gravitational waves. But if you ask me why mass has this property, why it reaches into the structure of space-time and warps it, I must be honest with you. We can predict it, but we don't fully know why. The relationship is there, tested to absurd precision, but the deeper cause, the reason existence itself bends under the weight of matter, remains open. What I can tell you is this. Once you see gravity as geometry, everything else must follow. The universe stops being a stage where forces act and becomes a dynamic shape, constantly curving, flexing, responding to everything inside it. Stars are not held in galaxies by invisible strings. They move through valleys in space-time. Light does not travel in straight lines. It travels in the straightest lines the curved universe allows. And you, standing still, are accelerating. Always, the ground pushes up, you push back. And that constant acceleration is what you have called weight since the day you were born. Remember the elevator? The one with no windows, where you could not tell if you were accelerating upward or sitting in gravity. That was not a trick. That was the answer. There is no difference. Gravity is acceleration through curved time. You are pressed into your chair, not because the Earth pulls you, but because the Earth's mass has slowed time beneath you, and you are constantly being tipped forward into that slower region, and the chair will not let you go. Now think about those GPS satellites again, the ones ticking faster above your head. They are not just tools, they are proof. Proof that time is not universal. Proof that the flow of moments depends on where you are, how deep in the well. Every navigation ping, every corrected position on your screen is a direct conversation with curved space-time. You hold the evidence in your hand. And here is what that means. The sensation you feel right now, the pressure in your legs, your back against the chair, is not the Earth reaching up and grabbing you. It is you, trying to move freely through the geometry of time and the surface of the planet stopping you. You are not at rest. You are being held in place constantly against your will. The ground is not passive. It is pushing, always pushing, and that is the only reason you feel anything at all. So let me leave you with this. Gravity does not pull. It never did. There is no hand reaching across space, no invisible tether. There is only shape. The shape of space-time, bent by mass, and time flowing slower in the valleys. You are not standing still. You are accelerating through a curved universe held back by the ground, and every moment of your life has been spent inside a geometry you mistook for a force. That mistake is over now. You know what gravity is. It is the curving of time itself, and you cannot unfeel it.